Welcome to Cannes Lab. This is the continuation of the last video, the one that we talk about surface tension. Remember, we define surface tension as the intermolecular forces that occur in between the molecules that are at the surface. Those molecules on the surface are not happy molecules. Molecules that are in the middle, they interact with all the other molecules around them. But the molecules that are at the surface, they don't want to leave the system. They want to stay together, so they try to minimize the surface. That's why when you make bubbles, they come into a spherical shape. You don't make bubbles into a square, they form spheres. Now we need to introduce another term related to surface tension, and this is related to the actual force that keeps those molecules together, and this is called cohesive force or cohesion. Cohesion is that energy that keeps those molecules together, molecules of the same system. If you have different systems, for example, the interface between the penny and the water, or the interface between the glass and the water, that will be adhesion. So cohesion is the force that keeps molecules of the same type together. Adhesion is the force between different molecules. So you can have the interface between the glass and the water, or any other type of materials. That's the reason why glue is also called adhesive. Different type of materials are bonded together. Why is this important? Why is that we need to know these terms? A very, very important function of cohesive and adhesive forces occurs in plants, biology. That's how a plant gets their nutrients from the soil. The water travels up to the leaves from the roots through capillary forces. And capillary forces is basically a combination of cohesion and adhesion. In the soil, we have the minerals and we have the water. The water dissolves the minerals and transports them up to the leaves. Let's zoom in into the stem of the plant. Water is going to adhere to the walls of the stem by adhesive forces. The cohesion, this means the sad molecules, this one at the surface, they don't want to let go. So the cohesive nature, that means the intermolecular forces of the water, they're going to follow up to the adhesion. So the water is going to rise continuously. In this process, the adhesion is larger than the cohesion. That means these parts here are going to pull the water through the cohesive forces. And then when it rises, it's going to adhere a little bit higher, and then cohesion is going to rise again. And then it's going to adhere, and then cohesion is going to rise. And cohesion is always trying to catch up with adhesion, and that process is called capillary action or capillarity. I mentioned something important. I mentioned that it's not only water that rises to the leaves, it's the minerals that are dissolved in the water. So for that, we need to introduce another term, which is called solubility. Solubility is highly dependent upon surface tension. If we start inputting equations of fluid dynamics or fluid statics, we're going to represent surface tension as gamma. The work of cohesion depends or is directly proportional to surface tension. Same thing goes for solubility. The solubility parameter, or the Hildebrand parameter, is also proportional to surface tension. Solubility is also a very important parameter. Why? Because mostly everything around you is a mixture of different components. And you need to understand what can dissolve what. In this case, the minerals that are in the soil are dissolved in the water and they're transported to feed the plant. There are many other cases. For example, when you drink lemonade, the sugar gets dissolved in the water. When you use shampoo, it's not only one thing that goes into shampoo. There are many different components that are there. When you eat pudding, there's many different components that are there, and you don't want them to be separated. So these parameters are really, really important, and all of them deal with the intermolecular forces in between the molecules. Either alike molecules in the case of cohesion, or different molecules in the case of adhesion. There are many applications that need these scientific concepts. What applications can you think of? Let me know. See you in the next video.